Greetings, splendid denizens of the cosmos. You're tuned into Wadafuk, your premier conduit for captivating and enlightening knowledge. This is a place where we dare to probe the uncharted, confront the unchallenged, and shine a light on the enigmas of our cosmos. Today, we're turning our gaze towards a celestial entity that has frequently stolen the limelight in Hollywood blockbusters. Yes, we're discussing asteroids, those roaming cosmic bodies in our solar system. But what if such a roving asteroid was detected hurtling towards cherished planet Earth? Today's episode is dedicated to the captivating domain of asteroids and the scenarios that may unfold if one was detected on a direct collision course with Earth. But before we dive in, let's about a popular topic that often surfaces in such situations: conspiracy theories. There are whispers suggesting that organizations like NASA might conceal critical information about an impending celestial danger to avert widespread panic. However, these theories are generally unfounded. In reality, transparency and communication are paramount in such grave scenarios to foster global collaboration on potential solutions or preventive measures. Claims of a cover-up usually lack substantial evidence and contradict the principles of responsible disaster management. So, as we delve into the world of asteroids today, remember that we're here to illuminate, not obfuscate. Imagine this: astronomers spot an asteroid heading towards Earth. What happens next? Well, the process begins with the detection of the celestial body. Telescopes across the globe, both on land and in space, are constantly scanning the skies. These telescopes, coupled with advanced radar systems, are the first line of defense, detecting and tracking asteroids that may pose a threat to our planet. Once an asteroid is identified, the data is quickly forwarded to international space agencies such as NASA in the United States, the European Space Agency in Europe, and others around the globe. These agencies have dedicated teams of scientists and engineers whose job it is to monitor space activity and assess potential threats. The initial response to a detected asteroid involves a series of steps. First, the threat must be verified. The data is analyzed and cross-referenced with other observations to ensure the detected object is indeed an asteroid and not a false alarm. Accuracy is paramount in this phase, as any error could lead to unnecessary panic. Next, the asteroid's trajectory and size are calculated. This information is crucial in determining whether the asteroid poses a real threat to Earth. An asteroid's trajectory will reveal if its path intersects with Earth's orbit, while its size will indicate the potential damage it could cause. For instance, an asteroid needs to be at least 60 meters in diameter for it to survive the journey through our atmosphere and cause significant damage. Finally, the relevant global authorities are alerted. This includes not only government agencies, but also international bodies like the United Nations. The goal is to ensure that all necessary parties are aware of the situation and can begin preparations for a potential impact. So the process is not as simple as spotting an asteroid and sounding an alarm. It involves careful observation, precise calculations, and clear, coordinated communication among a host of international institutions. Once the threat is confirmed and global authorities are alerted, it's time for the next phase, formulating a response plan. So, an asteroid is heading towards Earth. Panic? Not quite. Here's what happens. When we discover a potentially disastrous asteroid, the first step isn't to panic, but to formulate a response plan. We don't just sit back and watch the sky fall, we act. The response plan involves two major strategies: deflection missions and evacuation plans. Deflection missions are our first line of defense. They aim to nudge the asteroid off its collision course with Earth. This isn't as simple as it sounds. It's a delicate process that requires precise calculations and timing. The size of the asteroid plays a huge role in deciding the method of deflection. For smaller asteroids, we might use a kinetic impactor, a spacecraft designed to collide with the asteroid and change its trajectory. For larger asteroids, we might need to use a gravity tractor, a spacecraft that uses its own gravity to pull the asteroid into a different path. Evacuation plans come into play if deflection missions are unsuccessful, or if we don't have enough time to carry them out. These plans involve moving people away from the predicted impact site. The area of evacuation and the number of people to be moved depends on the size of the asteroid. A larger asteroid means a larger impact area and more people to move. Choosing the right response plan is a game of numbers. The size of the asteroid, the time until impact, and the potential impact area are all factors that need to be considered. And it's not just about saving lives, it's also about minimizing economic and environmental damage. It's a weighty responsibility, but it's one that scientists and governments around the world are prepared to shoulder. After all, when it comes to asteroids, prevention is always better than cure. So, we plan, we prepare, and we act. And while we hope our plans will never need to be put into action, we're ready if they do. With a response plan in place, the world prepares for the asteroid impact, hoping for the best but preparing for the worst. The day has arrived, the asteroid is about to hit. What can we expect? In the immediate aftermath of an asteroid impact, we can anticipate a series of catastrophic events. The initial impact would create a massive explosion, equivalent to thousands of nuclear bombs detonating simultaneously. This would be followed by shock waves spreading outwards, causing widespread destruction. The impact would also throw vast amounts of dust and debris into the atmosphere. This could potentially block out sunlight for months, even years, a phenomenon known as an impact winter. This lack of sunlight could lead to a significant drop in temperatures, disrupting ecosystems and leading to the extinction of numerous species. The potential loss of life would be immense. The immediate impact zone would see near total devastation, with casualties reaching into the millions. The long-term consequences, including the effects of an impact winter, could put billions more at risk. But it's not all doom and gloom. Humanity has shown remarkable resilience in the face of disaster. Recovery efforts would be swift and comprehensive. Emergency services would mobilize to rescue survivors, provide medical aid, and distribute food and water. Rebuilding would be a monumental task. It would take years, perhaps even decades. But we would rebuild. New cities would rise from the ashes of the old. Humanity would adapt and overcome, as we always have. The impact of an asteroid is a daunting prospect, but it's one that humanity is prepared to face. Well, that's quite a journey we've been on. From detection to impact and beyond, we've delved into the intricate process of detecting a potential Armageddon-causing asteroid, illustrating the crucial role of continuous vigilance and advanced technology. We've looked into the formulation of a response plan, a colossal task that relies heavily on scientific prowess, strategic thinking, and global cooperation. We further explored the potential impact and the inevitable aftermath, a testament to the resilience and adaptability of life on Earth. The maximum size an asteroid must be for Earth to survive? That's a complex equation, but we've tried to simplify it for you. This journey underscores the vital importance of preparedness and international collaboration in the face of such a cosmic threat. We've seen that the universe, vast and awe-inspiring, can also be a source of formidable challenges. Thank you for joining us on this cosmic journey. Remember, the universe is a vast and wondrous place full of mysteries to explore. Until next time, this is Wadafuk signing off.